Today's lesson is on power functions, and we want to answer the essential question, how do you graph a power function? And in order to answer the graphing part of it, we have to learn what a power function is, which we'll do in just a second. But before that, we need to be reminded of a concept we've already learned, and that is what a monomial function is, and what a monomial function looks like. So a monomial function can be written in the form f of x equals ax to the n, like that, where we call a the leading coefficient. That was a vocabulary term we had before. And n is called the degree. And there were some restrictions on what n could and couldn't be, and so n needed to be a non-negative integer. So it could be 0, it could be positive, but it needed to be an integer and couldn't be negative. With the review of a polynomial or a monomial function in mind, now we want to look at what a power function is and look at its definition, some of its rules, and a few examples and non-examples power functions. So a power function can be written as the function f of x equals kx to the n, like that. And that should look very similar to the monomial function, but now we call k the constant of variation. So that's the new name for the coefficient k, and n is the power. So it looks pretty much the same form as a monomial function, which was f of x equals a times x to the n, but this is k times x to the n. The letters aren't important, but now we call the coefficient the constant of variation, and n we call the power. And one of the reasons why we have new names for these things is because the rules are a little bit different. The only rule for a power function written in this form is that k can't equal 0, which would make the entire function equal 0. So as long as that doesn't happen, there are no restrictions on the exponent. And that's what sets a power function apart from a monomial function. No restrictions no restrictions on n, the power. Now the location of everything needs to be the same. X needs to be the base and n needs to be the exponent. But as far as the numbers for your coefficient, k can't equal 0, and for your power n, there are no restrictions on the power n. So a real simple example to begin with would be something like f of x equals x to the 8th power. Looks a lot like a monomial because it is a monomial function and it's a power function. This is both. And so we would say that the constant of variation here would be 1, the leading coefficient is 1, and then the power is the exponent, which is 8. So for that example, that's the leading coefficient, the constant of variation, and the power. Another example might be something like f of x equals the square root of x. Okay, now you say that doesn't look like it's written in the form of k times x to the n, but remember that the square root function can be rewritten with a rational exponent, x to the 1/2. So now in a situation like this, your constant of variation again is 1, but what's the power? The power is a fraction, it's 1/2. So even though the function didn't necessarily look like it was written like f of x equals k times x to the n, it was just slightly in disguise. another example would be something like f of x equals 6 over x cubed. And you say, well, that also doesn't look like it's written in the correct form, but remember that an x to the third power in the denominator of a fraction can be moved up and made to have a negative exponent, like this. And remember, there's no restrictions on the exponents, and so now this is a power function. The constant of variation is the 6, and the power in this case is negative 3. And to finish off with a few non-examples, something that would look, instead of resembling a monomial function, would look something like a polynomial function. Of course, is not a power function. There's too many terms. A power function can only have one term. Something that also, as I mentioned before, has the base and the exponent in different locations so that the variable is in the exponent instead of the base. This would be another example of something that's not a power function.